Okay, in this video, I want to cover more about parent functions and being able to compare functions to each other with different representations such as function equations, function tables, or graphs of functions. I have a handout that I made that has different questions related to different functions. So let's go ahead and look at functions in different representations and how to compare them. Okay, so if you look at number 1, it asks us to find a value called a of 4. And in order to know what a of 4 is, you have to know what the function a is. Function a is actually up here. So what we're going to do is rewrite the expression square root of x plus 5 minus 2. And to calculate a of 4, 4 will be substituted where my x term was. So in the red, you can see that I rewrote the expression, but where x is supposed to be, I use a set of parentheses, and we're going to rewrite using 4 instead of x. And to simplify this expression, we would start with inside the function. So 4 plus 5 is 9. So this is actually the square root of 9 minus 2, which is 3 minus 2, which is 1. So a of 4 we would say is 1. To answer something like number 3, it says what is the value of c of 3? So if you follow my markings here, on the table you'll see that in the x row, the row of x values, this is the x value equal to 3. And the value that goes with it is its function value. So this 12 is c of x. So when x is 3, c of x is 12. Therefore, for number 3, you can just say that the answer for c of 3, the value of c of 3, is just 12. Now, when we go down to something like number 5 or number 6, we'll look at number 5. 5 asks us to find the value of f of negative 5. And on the right there, you see I have a purple graph and a green graph. The purple function is f of x. To find what f of negative 5 is, we want to look where x is 5. And that's right here, right? This is where x equals negative 5. And imagine there's a vertical line that goes all along x equals negative 5. You're trying to find where the function hits the x value of negative 5, and that's right here. So this point is on the function. It is negative 5 comma 6. And so in a point, any point of a function, what a point represents actually is the x and the f of x value. Or in our case, this would be negative 5 comma f of negative 5. So f of negative 5 is the 6 because it is the y-coordinate of the function at x equals negative 5. So 6 would be the answer to number 5. Okay, let's go ahead and address a true or false question here, where we're comparing functions by their values. So let's look at b of 1 and see if that's equal to f of 1. So to calculate b of 1, we have to look at the function b, which b of x, I'll just rewrite b of 1. It would be negative parentheses x minus 3 squared plus 2. And 1 is the value that we're substituting as x, so that would go there. So if I were to work that out, that'd be negative the quantity of negative 2 squared plus 2, which is negative 4 plus 2, which is negative 2. So this is negative 2. And we're trying to determine if that's equal to f of 1. So to calculate f of 1, we actually have to go back to our graph up here. F is still that purple graph. And at x equals 1, which is here, you can see there's a point here, which is 1 comma negative 2. It's actually on both functions, but we're only caring about f, where 1 comma negative 2 is a point on the function f, so the value is negative 2. And that is a true statement. Negative 2 does equal negative 2. So that's a true statement. And just to take time to re-illustrate how to do this, I have some tables that I asked you to complete. Now, the functions a, I'll rewrite them. The a of x function is the square root of x plus 5 minus 2, and the b of x function is negative the quantity x minus 3 squared plus 2. Now, to complete a table by hand, what you would do is you would substitute all the values of x and get the value back and write that in the table. And that's very time consuming. And there's nothing wrong with having to do that or knowing how to do that. But what I illustrated in class is I really would like you to be able to use tools when helpful to actually complete tables just by having something like Desmos do it for you. So I'm actually going to jump on over to Desmos, and I'm going to show you how to do this step by step so you can do it on your own. I'm going to go ahead and go to Desmos, and I'm going to type in the function a of x equals square root of x plus 5 minus 2. So here I go. All right, so here I go. I'm going to type a parentheses x, right, function notation, equals square root expression, x plus 5. Now that's inside the function, and then outside it's minus 2. And of course on Desmos, it'll always autograph it, but I want a table. So the way that you do this is if you hit this gear icon where my mouse is right now, it says edit list. If you click that, you get this little table icon and it says create table. So if I hover over there and actually click on it, what it does is it produces a table of all the values from -2 to 2. Now, on my notes here, I want to go from x equals -4 to 4, so we can adjust our table on Desmos, which I'll go back and do. Okay, so as you can see, my table begins at x equals -2, so what I can do is I can delete the x values I don't need, and I can start this table wherever I want. So I can type in -4, and you can see it starts me at a value of 1, and then I can type -3, -2, -1, 0, 1, 2, 3, 4, and I have all the values that I want in my table. So those are all the values that I would then put into my table. So doing it by hand might not be necessary, but we can write -4 is -1, -3, we can estimate that or approximate it to maybe -0.6. -2, we might approximate that to -0.3. And at -1, it's 0. So you can see this is very useful because instead of doing it by hand and doing function evaluation by hand, it's nice to be able to use a tool like Desmos. So I really hope you take the time to actually use Desmos appropriately here, where you can actually just make Desmos do a function table for you. And one more thing to add before I move on is I want to show you something. If you go back to what we did here in number 1, and we said that a of 4 equals 1, we did it by hand using writing out the expression. I just want to show you something. In Desmos, if you type a function like a of x, you can actually call that function, so a of, and any value you put in those parentheses, Desmos will actually find the value of. And you can see here that a of 4 equals 1, just like we found in our work on the side there. So pretty cool trick that Desmos has available for you if you just know how to use it. I want to take some time to talk about number 11 and number 12. Given that f of x is a transformation of the absolute value parent function, write the equation f of x. So just as a quick reminder, the absolute value function is something like y equals the absolute value of x. And we have to realize that f of x is a transformation of this. So let me go back to our graph, and let's talk about the function f of x. So f of x is an absolute value function because it has like this V shape, which looks like two lines stitched together at a vertex point. So let's talk about the vertex of this function. So the vertex is right here. It's known as the vertex of the absolute value graph, and that is at 0, -4. Well, to make sense of what we're looking for, we have to look at the parent graph. So the parent graph of the absolute value of x starts at 0, 0 as a vertex, and it goes up 1 over 1 in both directions, and it would look something like this. So this is our parent graph called absolute value of x. So to make sense of our purple graph here, f of x, we have to talk about its vertex, which is 0, -4. And we also have to talk about the slope of the lines that go away from the vertex. So you can see here that these points away from the vertex go up 1 over 1. So for my graph, it goes up 2 over 1, up 2 over 1, up 2 over 1. So going from our parent graph of y equals absolute value of x, the transformation function f of x would be in the form something like a absolute value of x minus h plus k. And we've used these values before to represent the different transformations. So our function f of x would be, for the absolute value function, is the vertical stretch, which in this case is equivalent to the slope of these lines, so 2 times the absolute value of x. Now, from 0 to 0, which is the vertex of the parent graph, our function didn't move left or right, so this would be minus 0. And the k value is the vertical transformation or the vertical shift, and since it dropped by a value of 4, it would be minus 4. So another way you can write this would just be 2 absolute value of x minus 4. So that would be our function f of x. So number 11 would be, I'll just rewrite it, 2 absolute value of x minus 4. Okay, let's go back to our graph again and let's look at number 12. Given that g of x is a transformation of the linear parent function, which is our good old friend y equals just x, write the equation g of x. Okay, going back again. So g of x is really easy to talk about because we can just base it on our good friend, the slope-intercept form of a line. So slope-intercept form. So the easiest way to talk about slope-intercept is we can grab the y-intercept of the function. So what do we need? We need the y-intercept, and we need something called slope. And to put that all together, the function will look like y, or in this case g of x, so I'll say g of x. So g of x must equal something in the form mx plus b. So our y-intercept would be our b value, and slope would be the m value. All right, so I'm going to go to g of x. Our y-intercept is right here where it crosses the y-axis. So this is at 0, 1. So the value of b is just 1. So this will be 1. And then the slope of the line is something known as rate of change, similar to something known as rate of change. And in a line, we just call it slope. So from the y-intercept, what we can do is we can find the delta y and the delta x it takes to get to the next nice point, or the next point over. In this case, so we would just go, we're going to go down 3 over 1. And you can see here, you go down 3 over 1 again, and that'll get you to every next point on the graph. So that means that would be our delta y and our delta x. So our delta y over delta x. And if you're unfamiliar with calculating rate of change, I have a video you can check out. But delta y over delta x is rate of change, and in a line we call that slope. So the delta y, if you can see here, we're traveling down on the y-axis, so that would be negative 3. And we go to the right one, which is just positive 1. So our slope is the value negative 3. So this will be negative 3. And therefore our graph, our function is g of x equals negative 3x plus 1. So for number 12, we're just going to write negative 3x plus 1. All right, so number 15 has us evaluate more, so I'm not going to take any more time to look at that. You can check out my solutions on my class page that I have. But number 16 has us determine some function equations that we can try to solve using the information we're given. So number 16 starts by asking us the question, if f of a equals 2, give 2 values of a. So something to remember about function notation is what's in the parentheses in our function notation, this is usually referring to the x value, and this is the y value. So if I go back to what I'm talking about in f, that's a graph, so that's the information of the graph, and I'm basically asking this question, is there an a value such that the y value is 2, right? Where does that happen? Where are these points? So I'm going to go back to my graph of f of x, and if you're asking the question, where does my graph hit a y value of 2, what you can do is you can actually just consider, well, what if you had a horizontal line at y equals 2, right? Like this is the horizontal line, y equals 2. So I can ask, well, if my graph ever crosses this y equals 2 value, which actually happens here and here, we can actually ask the question, what are those x values? So if I find out where the first one is, this one actually happens at negative 3. And this other one happens at 3, those would be the values of a that I'm looking for. So the 2 points where this happens are the points negative 3, 2 and 3, 2. So going back to the question, give the 2 values of a. Those values would be a equals negative 3 or a equals 3. Okay, the next bullet point asks, if f of c equals g of c, give the value of c. So again, try to understand what this is saying. It's saying if you were to find f of a value x and g of a value x, when are they the same? So graphically, we're looking for the place where they both have the same x coordinate and the same y coordinate. So wouldn't that mean it's the same point on both of the functions? So I'm going to go back to my functions and let's look for points where both functions have the same coordinates. So if I look at my functions here, g and f of x, the only place where they meet is this point right here, which is 1, -2. And again, to help you make sense of what I'm trying to get to here, is if I ask you, what is g of 1? Well, looking at that point is on g. At 1, it has a value of -2. But similarly, if I said, okay, well, what's f of 1? Well, it's the same point, right? That point is also on the function f, so it actually has the same value, -2. So what I'm getting at is f of 1 equals g of 1, which is -2 for both. And the question I had is, what is the value of c such that that is true? This would be the x value that you plug in, right? So that's my c value, right? F of 1 equals g of 1. So at the x value 1, they both have the same value. So c equals 1, which I'll say because f of 1 equals g of 1. For something like this one that says if a of x equals b of x, give two values of x, quite simply, you could write the equation out and try to solve it, but I was hoping you would just rely on some tools, which I will do, and I'll hop on over to Desmos. So I have Desmos open and I already have the graph of a of x. Let me go ahead and type out b of x. So I want to make Desmos tell me what b of x is. And similar to the last one, Desmos gives us the graph of these two functions, and I can just look and see where their function values are the same. Well, that would mean that's where the points are the same on both functions. So both functions share the points 1.822, 0.612, and 4, 1. So the two values of x is 1.8 was one of them, and the other one was x equals 4. And again, that's because those x values give the same values of the function because those are the y values. And to make more sense of this, x equals 1.8 because a of 1.8, I'm approximating, was b of 1.8, right? They had the same point, so they have the same value. And to make sense of x equals 4, they both have the same value there, so a of 4 equals b of 4. So I hope that helps you understand functions a little bit more in their different representations. And I hope this helps you answer more questions based on the assignment that goes along with this set of notes comparing functions.